Are we? Oh, there we go. Recording started. Thanks, Jonathan. Welcome everybody to day 2 of our practical workshop introduction to scraping using Python, the crawling and scraping, and we'll get to that. I'm going to talk just a little bit, but I think first thing is to start up your notebook server, because that will take just a minute. And let me copy that and put it in the chat for everybody. Yeah, so if you click on that, it should spin up a little binder for you. It looks like mine was able to work. It's slightly changed from yesterday. All right. So while you're doing that, well, let me just reintroduce a couple people here. So Colton is a software CS guy at MDI, and George is an MDI scholar and master's student in data science for public policy. Do you guys want to just say hi quickly, because you're our tech support for the day, especially Colton?
Hey, yeah, if you have any questions, feel free to reach out. I've been doing web scraping and data analysis for a few years now. So if you have any insights that you're looking for, yeah, just message me.
Excellent, thank you. George?
Yeah, same. I've been doing web scraping for about 3 months. But if you have any questions, feel free to shoot me a message.
Oh, you're not that green though. How long have you been doing CS or like coding stuff?
Yeah, I've been a software developer for 3-ish years about now. So.
Right on. Okay, professional crowd right there. Just trying to elevate your your status. Awesome, thank you. Okay, and all right. So there you've got the tech support guys lined up when things go wrong, because they usually do, and we've got me and Jonathan here for all the other stuff. Yeah, let me start sharing. Let me start sharing my screen here. So you should be able to get to a binder screen like this when you click on that, on the link I sent you, or if that doesn't work for whatever reason, you have my repository, right? And that's the button that will get you there now and forever to the future. And anyway, what we focus on today is day 2. So I'm going to follow right along with you here. If you go to the Scraping Crawling notebook, not the solutions one, it should get you somewhere like this. So I know some screens are probably still loading, so I won't ask that question yet, but let's just start to work through this. Oh, look, it has a little memory thing. I think that's new. Right on. So today is all about these 2 critical sort of methods, or at least like perspectives on methods when it comes to scraping and crawling. And that is the difference between what I call narrow crawling and broad crawling. So in one case, you're designing specific HTML and CSS requests for a small set of websites to scrape them precisely. Just get the text you want and no junk. That's the goal. And remember from yesterday, HTML is the language of websites and CSS is what makes it pretty. So we're going to exploit both of those for our work today. Okay, so yeah, and the other difference is scraping really means extracting information you want from a body of HTML. And crawling is sending out little, well, it's like spiders. It's checking whether something's there, getting new links from a set of websites you do have. And it's just it's more expansive. So think of scraping as, yeah, think of scraping as like, let's say you go to a pie shop, right? And you decide that's a really beautiful pie, I want that one. So you buy it, and then you scrape the layer of cream off the top and just eat that, okay? Because that's your one pie, is all you care about. But the process you went through to select the pie, you went there and you looked at all of them and you're like, oh, show me more of your key lime, show me more of that one. And you checked out the population of pies first to decide what you wanted. So my point is this: these things happen together, and at the end of the day, you're eating pie. And it's just a question of how you want to do it and how broad your set of interests or websites in this case is. So there's a lot of text here. I'm just going to talk through some of it. Is it too early to ask people if you've got your binder open? Give me a signal, a thumbs up on your screen, or something if you're up to this point with me now. Looks like most of us are there. Okay, if you're having trouble still, send a chat message, and George and Colton will watch that. Thanks, guys. And I will keep marching ahead with this. Okay, so we're going to build on a couple of existing tools here. The golden rule for scraping, at least in my experience, is don't reinvent the wheel, or especially the flat tire. It's really easy to get excited about these problems and then design really low-level solutions that soon break or take a lot of work to get to work in the first place. So we're going to try our utmost to just build on things that are already there here in Python that make this job really easy and straightforward. Okay, right. So you can build a scraper from scratch, but it breaks, it takes a long time, and it's hard to make sort of like resilient and robust for different contexts. So really, the libraries we're going to use the most today are requests. That's what we use to make GET requests. So we're like, hey, website, give me your data, or hey, internet, give me that HTML right there. And then we grab that and we can do things with it. The next thing we usually do is we use beautiful soup on it. And that converts the HTML into something that's nice and readable, something like a parsed tree we can travel through pretty easily. We won't get too technical, but it's useful for a lot of practical things here. And the other one is, of course, is Scrapey. And that is just like a very fast, flexible, well-supported tool in Python, as I said yesterday. And we're mostly going to explore this website, and in a couple places, I'll give you some school website URLs to explore as well, see if our method is resilient. And if we're all lucky, we'll get to some of that at the end. Okay, and there's a lot of other suggestions and links in here. And here I define broad crawling and narrow crawling, which I just talked about. Oh yeah, when people say web scraping, they're usually talking about what I call narrow crawling. You've got a couple of websites, so you can be very precise in your calls to the website structure. But I'm going to try to make us prepared for a broader application here using a few different tools. Okay, so that's the introduction here. And now to our first thing. All right, so and you know, all these things today you can code along with me. So go ahead and hit Shift Enter on this first thing. Oh, you know what? I thought I cleaned out this notebook. I guess it didn't. So do something with me here first. Go to kernel and hit restart and clear output. I should have done that, but that might not have worked. Great. Okay. So everything should be blank. That way it's all new and none of the solutions are baked in. I'll make you think for yourself. Okay, so the first thing, we're going to ask for the Wikipedia page about the Potomac people, spelled different than we spell the name of the river these days. And okay, it seems like it came through. What does it actually look like here? I don't know what that means. I think 200 means success, but that's not very informative. Okay, so request.get got our URL. It turned it into HTML for us. We have this complex response now, and we can ask these questions. So request is really useful for a lot of different things. One of them is just like, okay, so was the response successful? And it's like, yes, it was. Great. Okay, can you tell me the date of the time that I scraped this thing as a reminder in case I have archived responses or something like that? Okay, well, it looks like you just did. I'm not really sure where GMT is, but that's a slightly different time zone. Okay, another thing I can do is convert into text very easily with response.text, and look at what that gives me. Okay, there's the beginning. That's a lot of stuff. It's telling me it's HTML. It's telling me the language is English, and it's telling me we're using UTF-8 and a lot of other things that are kind of hard to understand. So we'll drill down and try to make this more interpretable, more usable for humans and the kinds of things we like to analyze. But first, here's a question for you. Here's another website, another URL. You can just get a copy link address if you want, or do it this way, whatever you want. What I'd like you to do is get the HTML for it using requests, just like we just did for that Wikipedia page, and print out the first 1,000 characters. So I'll give you a minute to do that. Go ahead. Okay, what's missing here? If you manage to figure this out, you should be able to tell me what I'm not doing right.
You need the dot text.
Very nice. Thanks, Valerie. All right, what does that give me? Oh my gosh, that's a lot. Okay, there's one more thing I should do here. challenge is print out the first 1,000 characters. So, you know, that's pretty easy. We already did that. That worked. Okay, if anybody had a problem with this, let me know right now. Raise your hand or put in the chat. Otherwise, I'm just going to march on. Also, let me make sure I can see the chat right here. Just a second. Keyline pie was what I actually had in mind, Jonathan, for the record. And thanks, Valerie. GMT is in the UK. All right, moving on here. So the next thing we're going to do, as I said, is parse the HTML. So we've got all this beautiful mess here. And without trying to reinvent the wheel, right? Like I don't want to write my own algorithms to try to make this sensible or take out the pieces that actually are visible. So it is a little tricky though. So yeah, to understand how this works a little bit better before we do it, let's check out an example. So if you click on this website right here, and I'm just going to follow along with you, and then scroll down to sociology. So this is the Georgetown course schedule, class search at the bottom, give you all the sociology courses offered in the fall of 2021, and this is what it looks like. Okay, why did we come here? So that we could right click here, go to inspect. Your browser should show something very similar. And there's a lot of cool information here. So yeah, just to parse out the important pieces here, I actually did that already. And you can see there's a T body, something at the top, and then a bunch of TRs. So this is the T body means the body of a table, TR means the row of a table, and then it ends with TH, and that's a header or column header within a table is the TH. So we've got a couple different things here. And what are these? These are called HTML tags for the folks that are completely green like I was not long ago. And HTML tags are, they specify what kind of information is inside the bracket. So this one has some special designations here. This is actually a piece of CSS. And then A is for links. href is the actual specific hyperlink. It's usually what we want to take out there. Sorry about that. And then, oh yeah, but here we go. This is actually what we care about. This is the part that you see. So if you go back to that website, you see there's the title. And right now we just want the title. So that's what that looks like in HTML, just that first piece. And there's a lot more to it, but those are the pieces we care about. Okay, so there you go. So as far as parsing and getting these different pieces out from the HTML, even with handy tools like Beautiful Soup, you got to know the basics and maybe sometimes a little more. A is for hyperlinks, is one of the big ones. There's no P's in here, but the P tag is for paragraphs. So those are the main ones. All right, moving on with Beautiful Soup, and you'll have a challenge pretty soon here. Let's try to make sense of this HTML with this handy tool. So Beautiful Soup is easy to import. We do the same thing as before. We get the HTML. And this time we say, hey, Beautiful Soup, I want the text from that response like before, and convert it into soup object, and then prettify it for me. And I just want to see the front end. What does that look like? Nice. Okay, so that is quite a bit cleaner than before. We still have, you know, all the information is the same as in there, but it's like staggered in a way where it's got a tree. So you've got the root here, and then a branch, another branch, and so on, until we get down to the stuff that's actually shown, like this title here for this fact check page. Okay, nice. Right, so that's the nice thing about Prettify. Beautiful Soup can do a lot more stuff than that using the tags like I mentioned before. So let's try that out. So all you got to do is say soup find all and give it a name of a tag, like P for paragraph. And we're going to take the first 10 times that appears in the soup object in the HTML and then print it. So what does that look like? There we go. We still have the tags, but there's this is a lot cleaner, a lot closer to what we actually want. Is it perfect? This is important to notice. Even just taking the tags that seem clean, that seem like what we want, we still sometimes get, I mean, in this case, for some reason, the P tag includes a hyperlink. That's weird and not uncommon. And yeah, there's some other stuff here. Oh yeah, another hyperlink. So, okay, that's good to know. So we got some much closer to visible text. the problem is it's not perfect. So we're going to kind of wiggle with this a little bit, try to get a couple of different angles to approach this problem of how do you get from HTML to something that's used for analysis, like used for learning about charter school identities, for instance, or school curricula, or you can even a million other things you can learn about from the web. Okay, here's your next challenge. So using the same claim review page we just had going, print every 10th link. So you got to find them using soup find all and the A link this time, and their href element, and print every 10th link. So I'll give you, I don't think we've looked at this just yet, so I'll give you a little hint here. You'll need to index whatever comes out of the soup thing, each one of those A objects like we had before. You'll need to index that like you would a dictionary or a list. Actually, let's go with dictionary. And that's how you get the href out of that. So why don't you try? Go ahead. I started you off here, and all you got to do is find the first 10 hrefs or actual hyperlinks in there. So go ahead and try, and we'll see what it looks like. Okay, so what's missing here? I just basically copied what we did above, but with an A tag instead. So what do I need to do differently to get the links that we want, and yeah, what else? Anybody? Are you guys stumped? Oh, Nate's got an idea. Print link href. Let's try that out. Okay, that's much better. Okay, nice. So these are what we call relative links, meaning it starts with the same domain, a name, in this case, this whole thing. And then it's like, if you just tacked on membership onto that, in the context of the website, this is actually where this relative link would go. It would just append it to the domain name. And let's see here. Okay, there's one other piece here though. I asked for every 10th link, and this is sort of a nice trick. So I'll just kind of show you. Yeah, two colons. And so this is like, it's kind of a random sample, right? You're like, oh, just give me every 10th one. So it's got a little more variety to it. Anyway, we still have some relative links, some absolute links, which are mostly to Twitter. Oh, there's also a Congress one. That's interesting. Yeah, and then some that seem to go nowhere. These are usually indicate headers. And then some that have text alongside inside the hyperlink thing itself, which I think is just the title. It's no big deal. All right, so you can imagine cleaning this up a little more. So you can just get the absolute links. Like think about it, putting the relative links at the end of the domain, and removing things like this, and maybe anything after a space you would just ignore. But anyway, that is just gives you a sense of how to work with this. Parsing smartly, low effortfully. There you go. Okay, so the next part of our puzzle here, though, is in addition to sort of like working with tags to extract the pieces of information that we want, like p tags or a tags, sometimes we actually just want to get rid of them completely. So let's look at that a little bit. How do we go from HTML mess and then soup, even though it's better? How do we go from there to getting just the human readable text? Yeah, like we say we're not interested in the links or images tags in any situation because they just introduce noise, and we just want the text. Well, the best way to do this, or the simplest way anyway, which if you get into this kind of work, you'll use this one a lot, is what's called get text. And it is exactly what it sounds like. And there's other ways to call this, but I like this because it's explicit, and also you can think about, encourage you to think about what option should go inside the parentheses there. Okay, so same idea for each paragraph in that same soup. First 10, just get the text for me. And by the way, for each paragraph, strip any leading spaces so that it looks a little prettier. And that actually looks pretty good. So we've still got a link in here, but there's no tags anyway. Oh, and you've also got something from Shutterstock, which I think is a link to another website, which you could see for yourself if you want to. Right, all right, so we can also just tell soup like, hey, instead of just give me the first 10, just give me the first one, even easier. And oh, there it is, that's nice. Okay, a couple other things here. So back to the situation of tags are nice, but they're kind of in the way. Let's pretend we actually care about the tags themselves or their content. We can do this, this nice tool called extract, which removes the tag from the tree completely, but then you can store it to a separate variable. All right, so for each link in the first 5, just give me the, put the link on there and then print them. And then what we can do is check to see what the next 5 look like to confirm that they're actually different. So there you go. It's a little bit of a, I mean, 5 seems pretty long. It's still a little weird to me. I guess they're just trying to organize it well because it's pretty. But anyway, the links here. So these are ones that were removed. Some point to the Pointer Institute, and there's a donate link. That makes sense. So these were all kicked off, and then the ones after that are Illinois, Iowa, Missouri. So it's like if you're looking for fact-checking information for specific states, that would be the link you'd click in that on that website. Okay, the last sort of useful tool in this direction is decompose, and what that does is it completely destroys a tag. Frankly, I use this a lot more. I'm not usually interested in reading about tags or learning from them. It's more like anything other than text is in the way. So I can tell you what tags I want to get rid of, and it just gets rid of them. So again, let's define that URL, refresh all of this because we just removed some stuff. And then this time we'll just decompose them completely and then check what the results are. Okay, that was easy. In this case, we don't care about the things we removed like that. And I asked it just to get me the text this time to make it clean. So it ignored all the remaining tag information from the next ones like it got and just gave me the names. So that's much better. And Arby has a question. How do you discover things like decompose other than reading the manual? Stack Overflow. I poke around in Stack Overflow. Let's see, what was the problem I was trying to solve? I think I probably Googled something like remove junk tags from HTML. And I found a Stack Overflow post that was like, hey, use decompose. That's basically the tip. So I read into it, and there's quite a bit of help on the Beautiful Soup documentation. A lot more information there for anybody interested in learning more about this, like about the tree structure. You can actually you can do element.parent, and it'll point you back to the one that it came from. So like each of these links, I could say link.parent, it would point me to the soup object it came from. Or for these extract ones, like these are ripped out of a soup thing, right? So they would point you back to that one. So anyway, that's just an example. Amen to Stack Overflow. Hashtag amen, by the way, that's an interesting. Okay. Okay, so the point here is now we've got 2 ways of cleaning HTML. I don't mean to look like Nixon, but sometimes it happens. Just got off track with that. Right, so sometimes we can just say, give me the P tags, and that's nice. That's not universally great as far as getting you clean, visible text outside at the other end. So now we get another way, which is we could actually define the tags that we don't like and kick those off. So I would like you to try. And what I did based on a couple other Stack Overflow posts and experimentation is I defined this list for you of junk tags. And what I'd like you to do, whoops, oh yeah, I'm supposed to remove this. Okay, one more thing, if you guys would just go ahead and do this for me, delete the cell below the challenge, because that gives it away. That's not good. Yeah, I guess I wasn't as careful. And there's one more situation here I'm not as careful. So if you could, yeah. By the way, if you need the solutions like later, or if you're really stumped or it's frustrating, that's why there's a solutions notebook. But for now, just give it your best. So it should look like this. Yep. Okay. All right. So anyway, here's a list of junk tags. My challenge to you, in that soup object, remove every instance of a junk tag using decompose. Go for it. Okay, let's hear some ideas from folks, and I'll add that Jeremy has an excellent suggestion in the chat, which is like, okay, we're interested in this particular website, and he's being smart about it. So if you did something, if we want to study what this thing actually looks like, so here's the start of the text that we're interested in, right? We go to inspect. And you can ask yourself, okay, where's the good stuff start? Article class. So he's like, why not do soup.findAll article class, and then attributes class text block. So everything that's has a, where are the other text blocks? I think it might all be embedded in. It's all in here under the p tags. Oh yeah, but then there's, I guess like, Jeremy, I'm not sure that would solve the problem of these ones. Because these are also, I guess I don't have p tags on them. Anyway, that's my main thought and response is that's a great suggestion. So good thinking as far as having different access points for what I call narrow crawling, for getting something within this HTML soup that you can take advantage of. Okay, but back to our challenge here. So let's go ahead and define the blacklist and refresh on this thing. This is just what we did before. And then how do you try this strategy of removing non-visible tags of this kind of blacklist element? How would you guys do it? There's like a lot of different ways. And I'll just add here that you don't have to assign this anything, obviously, right? We already kind of saw that, but if you just do find the tag and then you do tag.decompose, it'll just kill it from the soup without you having to do anything else. So that actually broadens your options a little bit. So what do you think? How do you try to solve this one? And do you guys need more time? Like, give me if you need a little longer to work this out, give me a sign, wave a hand right now. So folks are pretty much there then. That's okay. Well, suggestions? Well, this Zoom thing sure is weird. I'm going to try it one way, okay? And you're going to tell me what else we could do. So I'll just try a good old-fashioned for loop. So okay, so great. So for each one of these blacklist things, I'm going to say, hey, like, find every element in there that matches this blacklist tag. And then what I want you to do is to kill it. And oops. And then show me the text from that. Oh, this is interesting. Okay. What does this tell you? It looks
is that all the blank space of everything that got deleted?
Yeah, that's one way this could have happened for sure. Like maybe Beautiful Soup just left the spaces in there where there was an element before. One way to check that is just to say, instead of printing it, I'll actually say soup.get text, and I guess not. So these are actually all the new lines. For whatever reason, it looks like it removed the junk, but then left in new lines, or maybe this was embedded in the HTML itself. So how would I do that differently? Yeah, and actually, I'm going to let that be a rhetorical question because I think I'm about to give you another challenge that goes in that direction here. Oh no, there's one other thing. Let me show you one other way of approaching this. So we've got all this extra white space because print shows us the new lines in display, right? There's a handy feature here called strip. And what that does is it takes each element and it removes the new lines. Okay, so that solved the problem. Wow, it's kind of overwhelming. So maybe I could do just like the first, give me like, skip the noisy header and give me a chunk like this. Okay, so what do you notice about the output here that might get in the way down the road of analyzing this?
They're no longer separated.
Yeah, exactly.
It's all just one big piece of text.
Right. Yeah, so it's, it's all good. We have all the information in there, but like if your time is short, should really be its own little text blob with a new line probably on either side. Instead, it got jammed right in between here. There's no spacing, which in the aggregate could be a huge problem. So right, the default, by the way, is strip equals false, which is how we got all this new line mess. So we're kind of damned either way, or are we? So let's try one more method here. And I will say, by the way, just in the spirit of efficiency, double for loops are really slow. So another way to do this is just to do a list comprehension. So hey, like for each tag, oh yeah, soup, I can pass in multiple tags, and then I'll say for each one of them, get rid of it. And let's say if we get the, yep, same results. Okay. All right, for this one, I know there are people in this room that have more experience with regular expressions than I do, so I'm going to challenge you this time. Now, let's try strip equals false again to avoid clobbering word boundaries like Colton pointed out. But do something else to clean up all the extra white spaces. which again are easy to see if you just show the output simply. So do something that gets rid of these. And regular expressions are a great tool for that, but you might find something else that's simpler depending on your background. So give that a try. Go ahead. And Jeremy had a good idea. Try that out, Jeremy. See if you can fix the problem just using .strep. All right, so think about how you are going to solve this problem, or just share some thoughts on how to do that while I catch up and see what methods might work. Okay, so we got rid of all the tag blacklist.
It is possible for text to have multiple new line characters in it as well, right? For example, within a paragraph tag or something along those lines.
Oh, totally. Yeah. Yeah, it's not clear to me just from this example whether the new lines were in the original HTML. I guess we could look back where it was before, but I think your point is it might just be embedded in the text rather than something that was an artifact of the scraping, right?
Yeah. In that case, my solution won't work, and I realized that after the fact. But I just split by new line characters, and then it filtered that for empty elements in that list. So I did list filter of none from this split on a new line. I was just trying to come up with something that wasn't a regular expression for fun.
Let's do. How's this? How does this
You can
work?
say none. So list filter and then none. So the first argument of filter is your function that you want to filter by, then comma, visible dot split, and then the new line character. And you'll need one more parentheses and one more closing.
I think you would need to define visible, right?
Yeah.
So is it so like this?
Something like that, yeah.
Oh, interesting.
The fault in that is if there are new line characters in as text in inside one of the elements, that'll also be split into multiple items within the list.
Yeah, that's a good point. I don't know. I usually use a new line character as a sort of like, I usually use that to split things up anyway. Like if there's a body of text and there's a new line in there, I assume that's legit. So that has the same problem as what you're describing. I'm not sure I know a good way around that. I guess in this case, it actually looks pretty good. Filter, no function, you split it on. Okay, yeah, so the filter gets rid of the empty stuff. That's cool, good solution. Other thoughts here. Oh, Colton, thanks, sir. I missed that. Jeremy says, can you have it print on a new line for every new line, for every paragraph tag? You got code. I'm sort of I'm not sure I see what you're suggesting. Or split at the blank and quotes. Yeah, Jeremy, give me some code, or if someone else knows what he means, go ahead and put that in there. I will share my simple suggestion. And I'll call this one Colton, which is to just use regular expressions. And anytime there's more than one, I just replace it with one. And then if you just print visible, and that works, that looks very similar to what Colton got actually. I feel like there's got to be a way to include dot strip in there, like for each element, without actually clobbering things like that. But I'm not sure about that. X is the 5. Yeah, I don't know. So Jeremy, stylistically, as far as like for every paragraph you wanted it printed on a separate line, I think that is what we're trying to do. Except we're not using the p tags at all. So that's like, I think what you're suggesting is you're sort of merging approaches there of like maybe, yeah, but once you get the text and obliterate, no, I guess we're decomposing, but this would still have the p tags in it, right? Okay, so now this has me curious. So what if, just along the lines of his suggestion, we still have this soup and we could do soup. Let's get all the p tags, actually, for p, and let's print the first 10 paragraphs after using the blacklist. What does that do? It doesn't like that. Why doesn't it like that? Oh, there you go. Yeah. Jeremy's got some great suggestions. Find the classic. X split 0. All right, Jeremy, I'm willing to try it, but you might have to walk me through this. And is it, we're going to call this the Jeremy solution. I'm missing something here, though. gdiv? What is gdiv? Jeremy, do you have access to your audio?
Here, yeah, or gdiv is soup.
Oh, okay.
Soup.find.
Soup.find?
So,
oh, okay, got it.
Well, this is how I would do it, is just find every div, the M text block, and split it between every quote.
You may have to escape the quote character, or yeah, you can put it in single quotes. Yeah.
Well, how would you escape it? I don't usually do that.
Or triple quotes.
Like
triple.
Escape is just add a slash before, like a /m.
Like that?
Yep.
Doesn't like the text piece. Soup.find div. Give me class. Okay, let's just see if that part worked. I mean, it seems like it. Can you, what happens if I just do soup.getText from there? Give me like, whatever, let's just see what it gives. All right, so that worked, but now what we want to do is this piece, get the text, and then we want to split it by quotes. Yeah, I don't know why that doesn't work offhand. It's an interesting idea. Maybe because I did .find, it already turned it into something texty. No. What if I did it this way? Dot split.
Or a triple quote, because you got a quote. You know, it's looking at the first, Python would be looking at the first two quotes. You just have the backslash in the first two quotes, right? Or the three, what is that little 3 dashes? Quote, 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 for a triple quote, to have quotes within a quote.
That's missing something. So then I have to escape.
Yeah, I think the triple quote is a multi-line comment for Python, so you need the escaped quote there. In the previous example that you have a space before and after the quote that could be affecting the things that you find or don't find. But the error that we're getting is that it's none type is being called. So
yeah, when I do oh, sorry, go ahead.
Oh, sorry. I was just gonna say maybe worthwhile to see what kind of type soup.find div class equals m text block gives back.
Yeah, when I run that soup.find on for divs with the m text block class, I get none back.
Yeah, so there you go. So if nothing's coming back, then it has no .text attribute.
Yep.
Find, oh, I haven't assigned this, so it's not useful. Okay, so this is giving us something, but we're not sure how to interact with it because it's not recognized as having a text attribute.
Well, it's giving us nothing. It's giving us none type.
Oh, right. Okay.
Or article class. Article class equals m.text block. Right, whoops. Sorry, I copied and pasted the whole. I just tried copying.
Cool.
Yes.
Let's see what you got. Let's try it.
You'll want something like that. So use article instead of div.
Okay, so I found something this time. What happens if I, oh, there you go. All right. Wow. That actually worked pretty well. What happens if I print that?
So real quick, in your text.split, get rid of those white spaces there and see what you get.
Oh, we've already got a bunch of, well, there's still white space in there. Let's see if that helps. Whoa, really? Look at that. Okay, so this is, again, we're looking at website structure, right? So we got article and classes and text block, and we got something very clean after splitting it on the quotation marks, which is interesting. Non-starter. Cool. So this is like the first chunk here. Nice. All right. Well, I know that was laborious. I hope we didn't lose too many people, but I spent time on that because this is exactly what the science is like. It's like trial and error. You look at the website elements, you try some things out. It's like a very messy laboratory where, the spore flying through the air landing in your petri dish is how you discover penicillin. Like that's the story. So it's thank you, Jeremy and Colton and George for creating that laboratory environment with us. And I've got one more challenge for folks to get, try that process yourself one more time. So here's another claim review. It's by a different, I'll just show you. Well, was this the one we were looking at before? Pardon me, I think it might be the same one. Infrastructure plane. Okay, yeah, so yeah, we did scrape this above. Okay, so you notice that we got, we still have headers and tags here. So what I want you to try to do now is clean the spacing. Actually, let's scrape a clean explanation from the body of this article. And you know what? Here's a solution, but I think we just did this basically. So let me just explain it because Jeremy actually did this under the hood. And so we're like find anything that's got an article tag and is of the class M text block and give me the text of that, and then clean up new lines. So same thing actually, but for folks watching, let me try to explain it a little bit more. So this is how it works. You find, you're like, okay, where's the text start at the article? What are these pieces called? Like, let me see. So there's a bunch of junk here and some other stuff here. But what about this piece? Like, is that part of the same object? Like, all of that. So anyway, I mean, this is where I would start. It's like, if you try just saying article class text block, and you see what the output looks like, and you can try one of these cleaning techniques like regular expressions or filter or that dot split thing. That's how it works. You just try out different things. Okay.
And one thing to note when you're in the element inspector in the Chrome browser, something that I often find myself doing is once you find the element that you want to try to extract text from, in that selector, you can right click and you can say, give me the CSS selector or give me, where is it? Maybe it's a Firefox thing, but I can right click one of those elements and then get a selector and it'll just give me like the nested CSS that I can then use in Beautiful Soup to actually select that element. I'll look and see how I can do it. Oh yeah, so you can copy different kinds of selectors. And those can be really handy in actually like pinpointing certain elements within your HTML. So that's a CSS selector, which is like a nested set of styling classes that can also be used to identify an HTML element. But there are other variants as well.
Oh my gosh! So we use some of the CSS here, but there's actually a bunch of layers. It looks like.
Yeah. So if you only wanted like articles with that text block that are like at this point in the document, you can get a very specific selector.
Oh, interesting.
Yep.
Wow, cool. So that's nested CSS selector. Oh, that wasn't what I wanted. I'm just seeing if there's other like pieces here. Copy.
Xpaths are actually another really great way to select HTML elements.
That wasn't useful. Okay, so let's say selectors and let's try copy the XPath and see what that gives us. Oh yeah, totally. If I did, and this is something that's used a lot in Scrapey as well, to point to particular parts that are useful. It's sort of like beyond the scope here, and I'm not that familiar with XPath myself, but it's very handy. All right. So anyway, we got this one more example of the explanation here, and this looks pretty darn good. Thanks to our web scraping, our diving into the HTML and CSS. Okay, so the problem here, I mean, the reason I introduced you to the blacklist method is it's generalizable, or you could say extensible, like it's usable, it's something you can use in a lot of different websites regardless of their structure. If you had 3 websites you were hitting repeatedly, or even like 10 or something, you could study them and find the selectors that you want. In a case like what I described yesterday, where I'm like scraping 7,000 websites and they've all got their own sets of pages and their own structure, that's harder to do. So while this method is much cleaner than what we did before, like you can look at the output of the decompose method. Yeah, it's still got like suggestive fact check and some other bunch of other stuff. So yeah, the blacklist method doesn't remove everything that we really want to remove. But that's like, you know, the benefit of sacrificing precision is scale or extensibility. Okay, so let's try, let's build some other tools here. So got about a half an hour, and that should be enough actually for what we want to do with Scrapey. And that is just, it's a great tool. There's a lot of, if you were going to do one other thing besides this workshop, going through the official Scrapey tutorial, I think, is really useful. I've borrowed pieces of it, but they go through a lot of things in more depth. I'll just say at the high level for now that Scrapey is a what they call a twisted application, or something that's virtually multi-threaded. So if you run Scrapey on your computer, it'll use up one processor, no matter, I mean, for assuming that you do the defaults, right? But it won't just, it's a lot faster than other applications because it doesn't block things. So to get a picture of that, imagine people at a bank. So you've got a couple different situations here. So in the case of like what they call a blocking operation on a single thread, so like using, I mean, this is how most things work. When something asks for a download, other things have to wait for it. When something needs to spawn a new process into a system operation, it holds up the whole line behind it on that thread. So if you've got one teller trying to help 5 customers, customer 1 might need to fill out a form or something, everybody else is stuck online. So that's the default situation. Even if you've got multiple threads, that means you got 3 tellers, same number of customers at this bank of ours. When customer 1 has to fill out a form, then teller 1 is occupied. So at most you've got 3 people being seen, and might be there for ages, and there's still people behind them that are waiting. What Scrapey does is what we call non-blocking. So yeah, rather than occupying system resources while it's busy, like waiting for a download or waiting for some other process, Scrapey actually lets that resource be free until there's a need for it. So it's very smart at queuing, at like using resources efficiently. So imagine again, we've got one teller, just with one teller and 5 customers. Customer 1 comes up, they have to fill out a form, it takes a long time. They can actually stand to the side and focus on that, and just let that process unfold at its own time, because that's its own thing. And the teller can be like, okay, when you're done, come back. But in the meantime, I'm going to talk to this person, customer 2, and so on. Customer 2 might have a form, they can stand aside, and then when customer 1 is ready, it'll say like, hey, I'm ready, system call, and then that thread will say like, oh, come back, we'll finish up with you, and then go on to customer number 3 while customer 2 is busy. So anyway, that's all in writing, if that was a little too fast for you. But the point is that Scrapey is very efficient and fast, and doesn't need to use a lot of system resources. That said, it's like sometimes you want to have separate Scrapey spiders going on, and each one uses its own CPU or thread. And they're all very efficient individually, but like en masse trying for speed, it can still eat up a lot of memory. So George knows about that, because our team has been working on this exact solution, trying to make it faster. And sometimes our 30 gig virtual machine still gets killed because we use everything that's on there to run 10 spiders. All right, so let's get back to practice here. So for this part of things, what you really want to do is go back to your browser. I think, yeah, you want to be on day 2, that's fine. It's not super important, but go to terminal, click new and go to terminal. And voila, you've got a Unix shell right inside your virtual server here, which is based in home Jovian. Don't ask me why it's called Jovian. If anyone knows, please tell us. But in here is all the stuff for date. Well, I guess it booted us over to the root directory, which is fine. Anyway, what you want to do is start a project. And well, what did I call this? I called this schools. Actually, frankly, you can call it whatever you want, as long as you remember what that is. Something short and to the point. And that will create for you, oh, it's like, yeah, a new Scrapey project. And the file tree will look like this. So you've got the root directory and then all these other little files in here. This should actually say schools. And within that, you've got your settings and your spiders. Okay, great. So Scrapey needs that so that it can track where things are. And just from that one step, it actually it has an items file set up, a bunch of settings, some middlewares you can play with. And these are all things that are easily customizable. So just one example, if I go to schools, settings.py, if I want to be a nice scraper person, I use the defaults and allow robots.txt obey true, right? You don't have to do anything. It's already there. If I'm trying to scrape at scale and I'm worried about missing something and I don't even want to think about what I might be missing, and I'm being nice already by including some pauses, you could turn this to false. And I only suggest doing that if you know what you're doing. So we're going to leave that as it is. But there's other things in here too that are really useful. And it's as easy as like uncommenting something like auto throttling. Pardon me. It's actually good to have on, but just for simplicity, let's leave that off. All right. So again, it's all there from this first command. And let's start with a narrow spider for this specific website. So we're going to be hitting quotes we're going to be hitting the quotes website repeatedly, so we're going to focus on that one. But for first things first, go ahead and in your schools directory, go to spiders and then create a new text file. And in there, copy all of this. And call it something like simple.py. Is that what I suggested? Oh, simple spider.py. It doesn't actually matter. Scrapey identifies what the spider is. You can have as many spiders as you want in this folder, but it'll recognize it based on the name that you define within the class. Okay, so when that's there, oh yeah, this tells you what these things mean. Yeah, the name is, well, the name is obviously important, but the other parts are important too. Parse is like, what are you going to do with this output? What this does is it just takes the URL and splits it and takes the second to last element. Page. Oh yeah, which I think is just page. That happens sometimes. It's okay. Oh yeah, and these are the URLs we're starting with. Okay, enough said. Let's try something. So back in our terminal, from the first level of your folder here, so that means you got to go into schools or whatever you set it as. Just do scrapey crawl simple and see what happens. Oh, spider not found simple. Oh, that's because I didn't save the file. Just click Control S or click Save, and it should give you a check mark here. And then if I try it again, wow, a lot of stuff happened. And I can look at it. There you go, all these scrapey settings. But look, it even tells you what some of the settings are. Nice, okay. So it made 3 GET requests and received 693 bytes. There you go. Okay, so you should see output like this, what I just showed you. And now let's look in the directory that it got moved to, which is just the first level here, schools. And because we defined, I'm going to close settings, because we defined the name of the file as quotes and then whatever the page number is, which in this case was just the number before the slash. That's what we told it to do. So the file name it used, and look at that. It got 1 page and another one. There you go. That simple. All right. So how this worked, yeah, the Scrapey request returned some objects. What am I trying to say here? Let's look at the code. Start URLs. Yeah, okay. So you define the start URLs. That's usually how you're going to do it, in one situation or another. And it sends a request for each one of these, and then for each one, it creates a request that it decides that it parses just automatically, as the parse function does, and then that goes through here, and they write it to this file. just all the HTML, where there's not much more parsing happening here. All right, that's what's important there. And then, okay, is anybody lost or needing help here? So I just went through a bunch of stuff. And I'm clicking kind of around pretty fast. If anybody's stuck, please go ahead and shout out or put it in the chat. Interesting question, Jeremy, but I think I'm seeing it 13 minutes late, so maybe I missed that. Okay, all right, well, if you're on board, go ahead and start this challenge here. And what I want you to do is use this, this terminal setting you just started up, and the spider script that you defined for yourself and saved, and update it. Use these URLs instead of the two that we put in before. Just throw those in there and then run it again and see what your output looks like. And these are 3 just very random schools. But we're making just one set of requests, right? Each person is just gonna run this one time. And we're all, because of the virtual servers, we're all on different IPs. So you'll be fine. If I was teaching this to 100 people, I would probably not do this because these are just random schools. But yeah, be nice and we won't kill them or shut them, make them turn off or get blocked. Okay.
I have a question for you, Jaren. You mentioned that these Scrapey spiders can run in parallel. Do you have any specific techniques you leverage so that you can write the response of the parse in a way that you may not interfere with the other ones that are happening concurrently? For example, in this example where we are writing to a file, could there potentially be conflicts where multiple Scrapey executors are writing to the same file at the same time?
Yeah, easily. I'm glad that George is here because you can probably extend upon my answer, George. But Colton, the main thing there is using a pipeline. So if you've got multiple spiders and you're trying to write to a single file, that's just, yeah, they're kind of gonna trip on each other. If you're using something like JSON lines, that might be easier. I haven't tried that as much. I think the sort of industry standard there is to use like a more, not actually just print to an output, but
Did Jaren freeze for anybody else or just me?
I can't hear him either.
Okay,
Yeah,
I wasn't sure if it was my connection. Oh no.
I guess while he's gone, one thing that we've been doing on our project has been using a Mongo database as our repository for the output. Scrapey actually has a pipeline that interfaces with Mongo using PyMongo, and Mongo takes care of all the blocking and from the distributed requests and all that.
I got you. That makes sense. So when you're doing anything at scale, you probably don't want to be writing it to a single file anyway. There are better storage solutions for that.
Yeah, definitely. I'm not sure how it behaves if you are writing to the file. I try to stay away from that personally.
Cool, thank you. Welcome back, Jaren.
hi everybody. Sorry about that. I don't know what happened, but I just had to refresh my internet connection or something. Yeah, Jonathan's right. I'm sure it was my cat. But I lost the chat so far, which is, anyway, we'll keep going here. These are remaining time well. Hold on a second. Share screen. There we go. That was not, yeah, I was looking for Google speed test. That's not helpful. Okay, Colton, to finish my answer, yeah, you got to list CSVs. You split them up and give them all the different spiders, and then you probably want to have it send to something smarter than just a single file.
Yeah, George was saying about using like Mongo databases and stuff like that, so we were able to talk it through. Thank you.
Okay, excellent. Yeah, good question. Okay, so I hope that people managed to get something here. I think, yeah, actually, let me go ahead and do this myself so we can look at it together. Very simple. Oops. Oh, and of course this died too. Bummer. Where am I now? Schools. Yeah, and then I just do Scrapey, crawl, simple. And then voila, we've got some school websites. Did anybody have a problem with this or maybe get blocked or anything? The point is that it's, it's actually pretty easy. These are not super pretty, but this is just a first blush at it. I guess wget wasn't always perfect either. Okay, any comments or questions? All right, well, that was pretty simple. So let's charge ahead. All right, so one useful tool here, I think we'll do this part kind of quickly because I want to get to the challenge at the end, is to, Scrapey Shell is very useful for learning about selectors. So before we were using the developer tools, in my case in Google Chrome, but Colton uses Firefox, other people use other ones. But as far as using Scrapey selectors in particular, there's this handy tool called Scrapey Shell. So let's try it. If you just go to your terminal here and do Scrapey Shell, I forget if I need quotes or not. It looks like I do. HTTP. You don't need a www here. It's just quotes dot to scrape.com. I believe that's it. Yes. Okay. It gives you this handy little interface here, and yeah, you should get something that looks like this. And now we can do handy things like ask it about, hey, what's the title of this page? And it's like, oh yeah, here's the whole thing. Is that what you wanted? I'm like, not exactly. I believe I just wanted the text there, and I didn't do that right, of course. So let's check the syntax. Oh yeah, you got to actually put in there with the selector. So like, okay, at the end of my selectors, just give me the text. And it's like, okay, here's the, here it is again. Oh, but I forgot one piece there. Which, okay, that's very nice that you gave me the text and everything, but I want you to get the individual pieces there. And it's like, okay, here's all of them as a list of one thing. And of course, if I just want the first element of that list, I would just do get, and that's cleaner. Okay, that's pretty easy. And there's different ways you could do it. You can do some regex there if you want. Yeah, but for studying, studying website structure, that's very handy. So, okay, now here's a fun challenge. And you might want to pull up the website for this, and you probably have this problem too. This link won't work unless you point it to the HTTP that's implicit in here. Okay, so I want to scrape some of these quotes. Now we ask ourselves, where are these quotes? And you can go through the website structure like this. You can use Scrapey Shell. Darn, I messed up here. Yeah, sorry about that. I think maybe Git didn't fully register my latest updates. So, but so far we're doing okay. Yeah, so the challenge is to find the selectors associated with the quotes and display one of the quotes. So once you can display one of the quotes, then you're good. Again, using something like title or whatever you need to find out where those quotes are that's unique. And remember, you can use a dot. So like div.something or span.something or header.something or title.something, depending on what it is and where it is. Div and span are some of the most common ones to select the class. So experiment with this. See what you need to do to produce a single quote in Scrapey Shell. Go ahead. All right, so what you got here? So if we want to find the quote, what's the first sort of piece of information we need? And this can be a little deceiving here because the title was really simple. And that's just because the title is part of the main chunk here at the top. Other things we usually need to index it by their section of the website. So we found a quote here. And what's the first sort of piece of information to categorize this quote in the website structure?
It's within a div, and it has the class of quote.
Very nice. All right, so let's try that. Response.css div.quote. I'm not sure I'm using these quotation marks correctly. No, I'm not. I think it's actually without those. That didn't work. What am I doing? What am I doing wrong there, people? Where's the chat? There it is.
It's a single string div.quote.
Yeah, nice. Oh, okay, great data. So now we've got, presumably there's quotes in here somewhere. So it looks like we need to do a little bit more sifting and sorting here. So if I want this piece here, oh yeah, there, this piece here, how would I do that? This one was part of a div, so this one is part of a span, right? And then I'd look for a text. So let's try that out. And I think it was it a comma? Nope. Let's try it without a comma. Nothing. Maybe it's like that. Nope. What am I doing wrong? Still got all this stuff here. How do I get just the quote that I want, the text of the quote out of this?
I think it's oh, I'm looking at XPath selectors where you use slashes, but CSS selectors are different. Is it a pointy bracket? Or,
Oh, where would that go?
1 second.
Well, you're finding a new way, which is great, but I think the way I suggest is with text and then .get. Great.
Gotcha.
Easy. Because we were building on that. Oh, I've been missing the chat. You guys have great ideas. div.quote was right. Span.text was great. Let's try Jeremy's way here. Let's try for div and then class. Oh, forgot the quote. I don't like that. I don't know. That one's a little beyond me. Jeremy, did you get that to work?
Well, I didn't get into the Scrapey terminal, or can you just delete div and just do class colon, delete the div part and do class text?
Let's try it. Ooh, doesn't like dictionaries.
You might be able to do div : text.
Yeah, sure.
I'm looking at the. I'm not sure. I'm looking at the Scrapey documentation.
Whoa. Okay, we got a lot of stuff there. That was the text of every div, right?
Yeah. So we need to whittle it down first.
Yeah. So maybe there's something. Could I do?
You could use class selectors there as well.
Yeah, I was wondering that. What if I did div and then like class?
You could do div.quote : text, I think, maybe. Or you span. You might have to get the span in there too.
Nice. We're back where we started. There might be other ideas here, but that at least works. And then if you want to, you can get all of them. Bunch of quotes. Okay, great. Let's move on here. Got 5 minutes left. And let me at least hit the highlights. So, okay, yeah, that's the HTML structure, if that's helpful. I probably could have said that earlier, but yeah, div.quote, span.text. That's how that works. You can also, yeah, like if you want to find the author, that's, by the same method, here's how you find, it's the same way that you find these things. You could find the title, the author, and the tags. And the way you pull that out is with these things. So that's useful. The other piece, sort of high level and useful, is wait, that was not what I was thinking. Sorry, 1 second. Oh yeah, okay. So if we got in our simple spider, rather than, what was the method we had before? Yeah. Oh yeah, we're just writing it to a file. Instead, we could like yield it, which actually can return it as well. Let's see. So you could run this spider as well on these different pages. And there's another way to do this, which is with items, which I think I might just touch on briefly. But the other high level piece is to save the data, right? Kind of like we've been saying. This spider we set up explicitly like tells you the file name itself. It's not usually best practice. Next best, or I mean a little better would be to save the file at the command line when you call it. So we could do that here. Yeah, I guess this wouldn't write it unless you did it to a file like this, which is fine. All right, but I think this might just be a conceptual bit at the end here. So the big takeaway here, the big benefit of using Scrapey in the first place is to do like a broad crawl. So far we've looked at a couple websites, the quotes one and the PolitiFact, and even that course schedule. Those are all specific examples, right? If you want a spider that can crawl anything, you actually need to use another template from Scrapey, which is like, it's amazing to me, frankly, that they provide this. So if you just did this command in your terminal, and you're welcome to, it'd be useful to learn. Scrapey gen spider T to tell it I want the spider I'm generating to be from a template. Crawl is one of their templates. Broad is the name you give it. and then quotes.scrape.com is the website that you want them to default to. So like the one it's going to scrape and the one it's going to look for links to within the website. So yeah, Scrapey is smart. So this is what it looks like. It would allow any domains you find on the website that are in this list. So it would go like quotes.scrape.com / page 1, page 2, about us, about you, whatever. And if it found a link that pointed to twitter.com, it would ignore it. If it found a link that has already scraped, it would ignore it. So Scrapey is very smart about these things. The hard part is creating a parser that can handle all these different situations. So yeah, the high level here is Scrapey can crawl broadly using a simple method like this. Parse items. There's a way actually to do this that just scrapes the text of any page. And that was the point of our blacklist method and the p-tag identification methods from above. Now you've got two methods in your pocket you could pull out. You could put either of them in here and then say like item text is equal to parser response, right? And yeah, so I could tell you a little bit about this, but it kind of gets in the weeds. What I really want to do here, we define the items in a file. Yeah, and this there we go. Yeah, it's kind of poetic that I left the solution in here too. And it works out well, that's just fine. So yeah, if you've got, if we're still trying to scrape this one website, we would still take advantage of like, you would define the item. So here, like you go into items.py and you say, I want this item to have these fields, one for text, one for author, one for tags. And then I would tell the spider to scrape these pieces from the page and then yield them. And you need to call it with -o as a storage parameter. Okay. Jeremy's doing a loop. That's great. That's another way to do it. So rather than looking for links, you could just say like, find me everything. I mean, the problem there obviously is if you like, you can't discover the links that a website has unless you study it. So like that website's very simple because it uses numbers. I mean, one of the only websites I've seen that goes from 1 to some number. Most of the time you actually need to find the URL of the subpages within the domain from the website itself. Okay, so that's what that looks like. And I'll tell you very briefly, also included in this repository in Extra is a bunch of useful stuff. One of them is this recursive text spider. And this will look familiar to George because this is what we built for our project. And it's way, it goes way beyond what I can explain to you in one session, but we at least started. So it uses a link extractor. It's based on crawl spider. Don't worry about these settings. It follows all the links, and for each one it calls parse items. And then for parse items, where is that? Oh yeah, it does a bunch of things, but the main thing is it calls this function we created called getText, which is named the same for beautiful soup function, which maybe is bad, but that's okay. And this does what we've been doing all day. Creates a soup object, removes the junk tags that I showed you, calls getText without stripping the white space to clobber things, and then it does some fancy things with encodings. But at the end of the day, it's really just removing consecutive spaces with regex. So that's just like, my dream in this workshop was to get you to a place where you could understand and write this spider. I think that would take an entire course, or at least 1 or 2 more sessions. But hopefully I've given you the building blocks to create something like that for yourself that could be deployed across all these different contexts. Jonathan says big 3. For this thing, frankly, I think I just made up this word. I hope it's a word out there, broad crawling. But yeah, hopefully this has been just like a whirlwind tour of what you can do with scraping, and I encourage you to clone the repo and play with these things more. Study this if you're interested in Scrapey. And I think I will stop there and say thanks to everybody for coming, championing in on day 2 as well as day 1. And darn, I forgot to create a survey to ask people for feedback and leave time for it. Jonathan, can we get on that and we'll send it out to people? You know what? We're going to email you a survey to give feedback on what you learned and what's useful and what else you want to get out of these workshops. So that'd be really useful to me. And with that, apologies for keeping us 3 minutes over time. I'm just grateful for everybody, and be in touch if you have questions. Thank you. And
Thanks, Jaren. Have a good one.